uses the same preparation, the same simulation.
What topic is that?
It's topic 10. Demonstrate the effect of extracellular potassium concentration on the contractility of intestinal smooth muscle using simulation program. So, in this case, for topic 10, you have to increase the potassium concentration, and note you have to know all the parameters, which is in at the end, or at least the first 3 pages of these parameters, which are included in the lab guide. And there you can find potassium, extracellular concentration, or plasma concentration. And you know, we can increase only the extracellular concentration, because the extracellular concentration in our case is blood, for example. In this case, is the chamber which contains the muscle. Okay, so we will increase the potassium concentration. And what will occur? It's a really small theory. It will change the equilibrium potential of potassium. Do you know what the equilibrium potential is?
Of the potassium?
Yeah.
Minus
Minus
6.
It's about minus something. Yeah. So it's the formula is R times T divided by Z times F times logarithmic extracellular concentration of potassium divided by the intracellular concentration of potassium ion. So if we increase the extracellular concentration, we increase the equilibrium potential. And you should know that these cells during normal conditions have normally permeability for the potassium ions. So the potassium's equilibrium potential is an important factor which is involved in the resting membrane potential. So actually, if you increase the potassium concentration, you depolarize the membrane by shifting at first the equilibrium potential of potassium ions to more positive one. And since it has a permeability to those ions, I mean, you can also write about the GH key, it's quite much the same. In the GH key you don't have the Z, yeah, exactly, but you have the concentration of ions, and potassium extracellular is also up there. So if you increase the potassium concentration, you increase the Goldman-Hodgkin potential's value, dipole. And if you depolarize the membrane, you increase the function of voltage-gated calcium channels. So more calcium will enter the cells. More contraction, exactly. It's a really small theory behind it. Then we have to add then potassium, which is number 9. But no, do you know the concentration of, and we don't have to use the...
You should wash out.
Yeah, we should wash out. But if you have this topic, you don't have to wash out, because then you will just enter this. Okay, so do you know the concentration of potassium in the extracellular fluids, like plasma? Just around?
60.
No. 3-5 millimole. Millimole. Actually, I think we asked for 3.5 till 5.3 millimole. But we have to add the concentration in micromole. So if we use the potassium, since we have to add it in micromolar concentration, we have to increase, like, not to 5, but 5,000. Okay? We can try 3,000 as well, but it's lower than what we already had, because the normal is between 3.5 and 5.3, for example. So we can set like 5,000. It will increase the potassium concentration, and it may cause a small contraction compared to the washout. Then we further increase the potassium concentration, choose 9 again, then 7,000, like 7 millimole. It will increase the contraction. Then we can use 9 for potassium and 12,000. The contractions are higher and higher. And then and again 20,000.
So if we enter the amount less than the normal potassium concentration in the extracellular, the program won't do anything.
Yeah. If you want to, therefore, if you just add 3, 5, 7, 12 instead of 5,000, 7,000, 12,000, it will alert you, and this is the solution to multiply it by 1,000, like 5,000, 7,000. Okay. I think, by the way, it's a really easy simulation. As you can see, our last topic in both cases is Joker. Choose your favorite topic and carry out the lab. It's the easiest, I think. So you have
The last topic was?
Joker.
Joker?
Topic hatom.
Choose your favorite topic and
It's a
carry.
really easy one.
But I heard they ask you more details if you pick Joker.
Sometimes, yeah.
What do you mean?
But I don't.
There is a Joker card.
Yeah. You will have cards. No, not Joker card.
Yeah,
Okay,
no,
so
but-
it's like poker. We don't have the Joker card.
Yeah, I know, but
It would be easy. But it's a good idea. Okay. So, I think the best is to write the Goldman-Hodgkin cuts potential and the formula, and tell them the normal potassium concentration. But if you increase it, it changes dipole, calcium channels, calcium contraction, and do the really nice experiment. Okay?
So this topic has finished?
Yeah.
Okay.